live stream en même temps pour que tu puisses te voir.
Yes. Tu peux voir ça. Thank you.
Je sais pas comment j'ai un truc.
J'ai cherché le live tout à l'heure, je savais pas si je vais sur le site et tout.
Je sais pas trop comment j'ai raté en fait. Ça c'était ce matin. C'est qu'on n'est plus vraiment en live.
Ah, mais en fait, c'est en live stream avec le.
Ouais. Je sais pas trop. Ouais, c'est en pause, du coup, je sens les streams. Je vais pas te le mettre.
C'est vrai. Déjà que je m'écoute parler.
On voit quand tu veux.
Hi everyone. Let's start. So I'm here today to introduce you the Linea project. And I'm going to start with this very simple question. Who owns you? So first, who am I? So here you have some information about my background. I've been an engineer in a R&D and telco company. I've been a PhD student in computer science, and today I'm working as a blockchain architect at Consensus for the Linea project. I'm also very into community events, association, mentoring hackathons. So if you have any question about that, you can just come and discuss with me during ETCC. And so today, I'm working on a protocol and a UX effort for longitudinal data management for Web 3.0 application. So let me introduce you Web 2.0, your toxic frame. So when I asked you who owns you, the answer is nobody. Nobody owns you. However, Web 2.0 is a friend that don't really let you own your data. It's a friend that you can spend time with, discussing, and everything that he's going to do is take your personality, your information, monetize it, don't give you any control over the process, and don't give you a penny about that. And there's something even worse, the single sign-on issue. I don't know if you realize that, but I believe that Google or Facebook are handling much more identities than some governments in some countries. So today, identity is being centralized by actors that are not government country, but digital actor. So all this is the web that we are currently living in. So the goal of Linea is to offer a decentralized platform for storing and sharing our longitudinal data of any type, which uses technology to achieve two opposing aims: protecting our privacy while letting our data flow to its best possible use for us. So what that means is, yes, we want to give back the control over the data to the user, but it doesn't mean that the user has to become a bottleneck. So what Linea wants is more governance for the people, but also an increased experience for application developer to leverage on user data. And I'm going to walk you through that. So first, we need to share some assumptions. First one is, our longitudinal data of any kind creates value. Longitudinal data is not data that you collect when you're having an accident, or where you're buying a house, or when you're getting sick. Longitudinal data is every data that you collect when you're living in your house, when you're driving your car every day, and any metric of your healthcare that you're collecting every day. So the goal is to gather information in a very, very long time period about each individual, thus enabling new kind of potential and opportunities for services in AI, big data, and things like that. So all this is good, but we need a place to store and share this data. Some people, they're like, okay, so we're just going to ask people to store their own data. But I don't think people want to have in their living room a server in the database to manage their own data. This is not a credible option, even for the most purists of us. However, they don't want data center to be controlling their data and monetizing the data without their permission. So what is the compromise that we can find here? Decentralization. If we can decentralize the storage of the data and the permissioning, we can solve the UX issue that we're having, which is the user doesn't need to be like really deep into tech to be able to manage his data. And at the same time, he needs to get back the control over it. So we are losing a battle, the UX battle. So even if Linea is a protocol, there is a huge UX effort, a huge UX research in Linea. Why? Because if you're not able to be better at UX than Google or Facebook, people, they're just going to keep using those services, single sign-on, because it's much more easier to click on a button than to create a wallet, and you need to secure your keys and all this stuff. People, they don't care about that today. So if you're not able to be better than them, then the Web 3.0 will never exist. So here is a view of the architecture that we are offering. So you can find at the bottom layer, identity. Everything is based on identity. If you can have self-sovereign identity, then you can build layer for self-managed data. Once you have self-managed data, anything is possible. Any vertical can be plugged in that. Linea is agnostic. We started with healthcare for obvious reason, but social data, your home data, mobility data, your photos, everything can be stored through Linea and accessed. And as you can see, this is not siloed. So the basis is common, meaning that you can create new kind of use cases. For example, I believe we can have like hackathon every week just finding new examples. We can have like people thinking, how can I link health data to mobility? Like how my movements, my driving affects my health or my sleep or the photo that I'm taking about my food, what is the impact of that? Like you can link everything and create new kind of services that today you cannot do. For one simple reason, if you're creating a new app, you don't have the data to do that. So you need to get adoption, you need to recreate a database, and it takes you time, and then you can be able to give a service. But here with this architecture, you can create an algorithm, very simple one. You can plug it to the architecture, and because people are using Linea and other applications running on top of Linea, you might already have like 6 months of data. You just have to get the permission from the user, and you can run your algorithm and give a result on the spot. So this is a new way of doing things. So we were talking about identity. So if you look at the technical paper that we just released in the team, we are introducing this concept of singleton. So in computer science, a singleton is a class that has only one instance of itself. And we like that idea because it conveys a sense of uniqueness, which is what identity is. In your real life, you're just one person. So in digital life, you should be also one person. However, you have multiple facets. Just like in your real life, if you're a doctor and you're a diabetic and you may be driving a Tesla, all those facets are going to be used depending on the context. When you're interacting with the Tesla services, only the Tesla customer facet is interesting. When you're going to the hospital, they only care about the fact that you're holding a degree in medical studies, so they're going to give you access to some files. So with the singleton and with HD keys, so we're really leveraging HD keys with the concept of master key and child keys to create that dual concept of uniqueness and having manifold facets. So how to reconnect the user to its data? Because that's the question. We're working on 7 verticals. I won't have the time to dive into each one during the session, but I recommend that you read the technical paper. So we have decentralized identity. We've been over it. Decentralized storage, you can also imagine that we are going to be working with projects like IPFS, Swarm, and other identity. It will be like Uport, Ubers, Civic. We have contextual attestation. We use attestation because for us, it's the data structure that is going to link identity and data, on-chain and off-chain. So it's like a certificate. Permissions and policies. Permissions policy are core to the layer because, as I say, the goal is to be able to give back the power to the user. So we need to work on that. What does it mean from a UX perspective? What does it mean for application developers? Because they are going to need to integrate with the protocol. Data and metadata, obviously. For us, the data is private by design, so everything is encrypted. And the metadata is something that we use for search and also to create a marketplace or a browser when anyone can browse for data and have the quality scoring, we call it the iris, to have a sense of the value behind the data. So iris is like carrot for diamond, if you see the analogy. So when you have a precious gem, you don't really have the dollar amount corresponding, but you can have the carat. And then from the carat, you get the actual market price, depending on the offer and the demand. So this is the same thing. You have your data, they have an iris value, an iris score, and then the market will fix the price if you're going into monetization of your data. So we are enabling that to happen. And data computation, it's a big R&D challenge that we have. How can we enable application to compute on data that is stored decentralized and because it's our goal, encrypted. So computation on encrypted data. So we know that people are looking into this, and we believe that having multiple projects working to build Web3, working to build confidentiality and self-sovereignty for the user is good, because everyone is going to approach the issue from a different point of view. And we are completely open to collaboration. We already started to do that. We have been talking to many of the projects that you can see in the list. So for us, it's just a global research effort to enable Web 3.0 to exist. This is a rapid view of the architecture. You can again, check it on the technical paper. You have the local storage of the user, could be like the client, could be a mobile, the mobile of the user. The keys are the one that I was talking about with the singleton, and then the user has the responsibility for the key, but the child keys are less critical, and we use them for data sharing depending on the application. So as many applications or services that we have, we will have the corresponding child keys. If we lose them, it's not a problem, because they're only child keys. And we have consensus computers. First one being Ethereum, but we cannot use it for everything because of cost issues. So we're also having a mesh of nodes. These nodes, and I was talking about policy earlier, these nodes are going to be vetted for some of them. For example, if we're doing computation on health data, we're not going to use just any node. So the policy in the user data will be, for example, I'm a French citizen, I'm under GDPR, and I just want my data to be stored in French nodes and computed on French nodes, and maybe even say hospital managed nodes. So policy are going to enable us to do just that. So at first, I was just saying Linea is for human. It reconnects data to your life. But now you see that we have many challenges. So we know that the project is very ambitious. And we're starting working with other projects. I mentioned that. So Ethereum Scalability Research and Development Subsidy Programs, the Vitalik grant, basically. We're going to apply, and we're going to do that with the actually next project that is going to present to you about state channels. So we're looking into that, and I insist on the fact that for us, privacy by design is important. So our contribution in terms of research is not only going to be about scalability, but how to provide scalable solutions that are protective of the confidentiality of the user by design. Not as something that is complicated and that will be handled later, but at first. This will enable us to be a solution that will help applications that want to be compliant with GDPR and don't really know how to do that, to say, okay, we can use Linea, because they are tackling this issue at the core. So we can discuss about that if you want. We have a roadmap. You can check it. Maybe it will be in better quality online. And today, what is the current status of the project? We have a team of 10 people. We are in 4 different countries, the US, Canada, Spain, and France so far. We released last week a vision paper and a technical paper, and we are eager to have your feedback on both of them. And if you want, you can go on the website, access resources, go on the GitHub, check the code. And I have 2 more news for you. First one, we have opened the Bounty Challenge, so you can come and try to build a decentralized application over the code that we provided, any kind of application, and we're doing that in partnership with Gitcoin. which are awesome, and they're like providing us with that bounty that we're offering to any of the coolest dApp that is going to apply. Second news, like most consensus projects, we are hiring heavily. So this is just one example of a job that we're trying to fill right now, a protocol engineer for Linea to work on the backend and the implementation with us. So if you are interested, or if you know someone that will be interested, you just have to go on the website and find a job offer and apply. It's like 2 minutes, and we'll be glad to have a discussion with you, also in real life, as some of my teammates are here, like Amira, so just come and discuss with us. That's it. Thank you for listening, and if you have any question, I'll be glad to answer.
You were talking about the fact that when new creators of apps access the information of people, they have to ask them whether the people are ready to share their information. How is this, I don't know, how do the holders of that information should choose whether they share their information or not?
Yeah, good question. So it is part of the UX effort. So when you're building an application and it goes on the store, and as a user you download it, they have this kind of accepting terms and things like that. So we want to change that and have a separate kind of store, you know. And when you download, when you accept, you just accept specific portion of the permission. So this is something we have to design with the application developers and with the users by doing like a focus group. And then we will define that kind of formula. We don't want it to be too long because when people want to download something, it needs to be quick. But we want it to be like for the people to feel that they're empowered in their decision. So this is the first step. Then they will be able to manage all their permission from another application, like a user-centric application by Linea, and they will have the list of all the applications connected to their singleton. So they can revoke permission when they want.
So, if a time comes when there are like 100 developers asking me for my permission, and one day, do I have to like tell them everyone to okay, like separately?
So I believe like when you download application, you just download them one by one. So no one is going to ask you for permission if you're not asking for the service in return. Yeah. However, in healthcare, we are looking into clinical trials, and if you accept before to be contacted by interesting research based on your disease or whatever, you can get notified by very specific people that said your profile is exactly what we are looking for this trial, and you can get like a treatment right now. So yeah, you're welcome. Yes.
Can you just explain a bit more about the vetted nodes and why you need that? Because kind of what Victor was saying in the previous talk in this hall, that this idea of kind of like restricting storage and computation geographically is like a kind of archaic idea for Web3 and stuff like that.
So, so there's two things. The use of that mesh is because we're doing computation on encrypted data. For now, we don't really know how we are going to do it, but we know that we're going to do it in a cooperative manner, so we don't want to have a centralized computation, so we need a network. So that was the first idea. Then we want those nodes to have some kind of trust level, because we're going to handle personal data. So this is the idea behind vetted nodes. Again, we don't really know what will be the criteria. And then there is the GDPR compliance. If in the law it is written that you cannot store or process data from citizens that are not in this country, then we want, archaic or not, it will be the law. So, for example, in Europe, if they don't want their citizens to have data processed in the US, then you need to comply and want to be able to say to app developers, it's okay, we are handling this feature. You can have it or not, but at least it's available. Yes? I really agree with that. But maybe you will have the opportunity to discover that during your stay in Paris. The regulators are very slow to move on those kind of ideas. Even saying that encrypted data is less critical, it's like they don't really believe in that. So there is like a pedagogical work to be done. And we believe that by meeting them halfway every time, we will be able to progress. And on the second aspect, because you were talking about secure multi-party computation, which is very interesting, my colleague Amira here is a cryptographer, and with other people in Consensus, and actually anyone that wants, we are building research around cryptographic methods for applied use case. Because people, and especially developers, we know they are tired of reading like mathematical paper. They just want to know if it's going to be useful for this specific use case. So we are going to try to build that bridge and do like a matrix or a map of that, and it will be available for everyone. Homomorphic, you mean? We're not going to use full homomorphic computation for, performance reasons. Thank you. Yeah. Exactly, especially for, I don't remember the term, but like collision. Like for example, some attributes, you can have them encrypted, but then if they are limited in terms of range, anyone can try to guess them, like the age, the blood type, and things like that. So we're looking into an anonymization scheme and everything with respect to blind storage, blind computation. Yeah. Thank you very much.
Hello, hi guys. Nice to have you here in this room. My name is Gerald. This is Victor here standing next to me. Together we'll speak this morning. We will speak about IT infrastructure in multi-cloud environment. We're going to talk about decentralized service level agreement, which is very specific to our industry, but I'm going to go into some details just afterwards. And we are going to talk about off to on-chain data management with a specific focus on what we call state channels, and more specifically, multilateral state channels. Just before I begin, are there any system administrators or maybe DevOps in the room? Yeah? Wow, 3 people. Okay, I hope you guys enjoy the show because we're going to talk about some stuff about infrastructure. Okay, so yeah. Couple of words about us. We are a team of seasoned entrepreneurs. We built several startups so far, but not crypto native though. We're more coming from the DevOps, system administration, and startup ecosystem. There's about 12 of us in the team. The team is spread between France and Canada. There's no regular office. Everybody is working remotely. And our CEO, Stéphane, just wrote a book about IT infrastructures that you can find on Amazon if you show any interest. Okay, so a couple of words about our ecosystem and what we do. So in the last years, there's been a specific development in the way that people develop their apps and their web services or their websites. We call that the cloud native way of developing. So basically, it's all about working with microservices. That means that when you develop an app, you do not develop it as a whole system or one whole monolithic system, but more like several microservices that are interconnected but yet independent. That's very useful because when you need to move part of the microservices or when you need to adapt it, like scale it, for example, it's way easier to move one piece of a puzzle than the whole picture. I guess you can see it a bit like a Tetris game, maybe. Okay. So what we do at SquareScale is once the code is written, we help the developers switch to production mode by basically by giving them a one-click solution that allows them to deploy a complex infrastructure in one click and in a couple of minutes. Well, I know it's not very sexy when I talk about that, but it's a major breakthrough in the industry, since so far this kind of development needed like weeks of work of highly skilled people like system administrators. So through our solution, we also host the application, the services, websites, and so far by cloud providers, people like, I mean, regular cloud providers like Amazon AWS and Microsoft Azure, people like that. And so far we support only one provider in one data center, but step by step we are going to add several data centers and several providers in order to move towards what we call a multi-cloud environment. How is that interesting? So basically it allows people to host part of their microservices by one provider, part of their microservices by another provider, and have the whole thing work seamlessly, which is quite important because just in case one provider goes down because of a breach, then you got the other one who is able to step up and take its place so that your whole system is working seamlessly. Sajida just before talked about GDPR. We're also working on this on the next step of the GDPR. So GDPR is basically a bunch of regulations who are supposed to help people protect data privacy. And we believe that, as you said, Sajida, in the near future, people-related data will have to be kept, stored in their country of origin. So far, it's only mandatory for health data, but we believe that in the near future, any data will have to be stored in the country of origin of the people. And that means running several split databases. This is quite complex to do. And through our solution, you will be able to do that in one click, which is also part of the stuff that we could work together on with the Linea project. So we are now in public beta mode. So if any of you want to test the product, just make sure to come see me at the end of the show. We have vouchers for you guys to test the project free and try and run your apps with our solution. So let me sum it up for you. Basically, in one click, without any expert system administration skill, you will be able to develop a dedicated, scalable, and complex infrastructure, which will allow you to save time because you can do it in minutes instead of doing in weeks, and will also help you save some money because, well, it's fully automated, so you don't have to pay for the team. The business model of the solution is a pay-per-use business model, meaning that if in case you need to scale up your infrastructure, you will only have to pay for the excess or the additional amount of power that you need before scaling down again. So this is quite agile and it's not too expensive. So basically it's quite better, cheaper, and quicker than what's already in the market. Now, I'm just going into a little bit of detail about scalability. You may have heard I talked about scalability quite a couple of times so far. I'm not going into much details here, but just for you guys to understand what I'm talking about, scalability is basically either adding some, it's pumping up the volume on your infrastructure. So basically it's adding either some extra computing power or some additional entry points to support the arrival of extra visitors. Let me give you an example. I guess all guys, you noticed that in December last year, we had some kind of a massive media coverage about cryptos. Everybody was talking about cryptos. Everybody was going crazy about cryptos. There were TV coverage about that, and everybody started rushing on platforms like Kraken or Binance and stuff like that. People wanted to open up an account and start trading. You know, it was like the gold fever back in the 19th century. Everybody thought they were going to be rich. The thing is, those platforms, they were not prepared for the sudden explosion in demand, so their servers went down one after the other. Scaling up these servers takes usually weeks of work. It's quite tedious, it's quite difficult to do. Through Square Scale or this kind of solution, you could have done it in one click and in a couple of minutes. So that's basically what we do. Okay, there's an expression that says you don't need a blockchain for that. And so far, you don't need a blockchain for that, okay? Let me tell you into more details the major problem or the major issue that we are facing in our industry. This is a problem related with trust. Remember when I mentioned the image of a puzzle earlier on, or the Tetris game? I said that the microservices were all interconnected, one with each other, with another. Well, this interconnection happens through service providers. Those service providers, sometimes they are up and running, and sometimes they are down, you know? And sometimes when you need their service, well, you experience a breach in their service, but if you go check their status page, they say, no, it's okay, we're up. All the lanterns are green, and there's no problem with us. Well, the thing is that you in front of your computer, if you want your app to be running, it doesn't work. So it's just as simple as their word against yours. The problem is, if they are down, you can get a refund because for some of the services you pay for the services. Okay, so if they are down, if they are not delivering the quality or the service that you are expecting, you are supposed to get a refund. Okay, well, the thing is, it's just the very same people who are able to pay for the refund and also who declare if the service is up or down. You know, so you got a major problem of trust in this field. I guess you can see that. Well, this major problem of trust, it also applies to us because we are service providers. So the question is, what kind of trust can our customers put into our own services? And this is an issue that we decided to tackle by gathering a network of contributors in our ecosystem, and we're just asking those contributors, well, basically to perform the monitoring of our service for us, you know, to do that in an independent way, and they were going to operate this monitoring through a peer-to-peer network. And Victor is going to go into details about this peer-to-peer network just afterwards. Together, they are going to reach a consensus of information about the service. Is it up or running or not? The data is going to be published into the Ethereum blockchain, and, well, obviously, completing the full circle, this data will be fed to a smart contract, and the smart contract will trigger, if need be, a compensation for our customers. So that's just the way we want to do that. We feel it's better. We feel it's better because it's transparent, because it's well, it's outsourced to the customers, and because it's also fully automated. And we believe that this kind of system could be used by other service providers as well. So maybe they can just use our solution for their own services. One of the main technical challenges that we face, well, there are several of them actually, but one of the main technical challenges that we face on the blockchain side is how are we able to scale up the system within the blockchain without exploding the cost barrier regarding the transaction cost and the storage and the, well, obviously the power, the power as well. And so this is exactly what the problem that we've been trying to solve through what we call a state channel that Victor started designing. Just before he explains you how we are going to do that, I just want to give you one last piece of information. This whole blockchain architecture is still a work in progress, meaning that we are building it right now. This is not fully completed, okay? So if any of you guys have ideas, contributions, stuff like that to give us, feel free to interact at the end of the presentation. We'll be very glad to build it with you. This is anyway something that we want to be open to the community so that everybody can use it and customize it. So this is a work that we wish to do with several people. There might be some overlap or integration opportunities with people like Swarm, who just presented before. We just had the opportunity of a little chat with him, see which kind of integration opportunities we could have together. So, well, again, work in progress. I hope you will have some ideas for us. Okay, Victor.
So now we are going to enter in the details of the implementation of this challenge, state channel. So, as you said, Gerard, the good point about hosting our SLA contract in the blockchain is transparency, because each party of the contract is pretty sure the contract to be executed according to the way it has been defined. But the issue is that the blockchain is blind and it can't fetch the information to monitor the website or the API by itself. So you have to provide that information. And there we shift the problem from the contract to the information source, the trust problem. So the trust issue is in fact to grant the data to be independent from Squarescale, to be not to be vulnerable to attacks. And also we have to grant data integrity from end to end, from the moment when the contributor is fetching the data until the moment it is anchored in the blockchain. So there is a lot of challenge, and we are going to talk about that. So this is a global overview of architecture with only the actors. At the center, you can see the contributors networks. So this is basically a peer-to-peer network. You have to subscribe to enter inside this network. And when you do that, you start to fetch data for us. You have to download, for example, an add-on from your browser, a plugin, and this will enable you to contribute. And this is what grants the independency of our data, of monitoring data, because this network is self-governed, and Squarescale has not a word to say about governance. So when the data has been fetched, it is sent on both sides. On the left, you have Squarescale, which provides a dashboard, a live dashboard. So it enables the DevOps and the sysadmin to access the data directly from the contributors. And you have also on this side the job queue, where Squarescale will define which website has to be monitored and how do we monitor them. And on the right, you have the on-chain side of the project with our smart contracts. So it has to manage the relationships with our contributors and also to the SLA itself. We will anchor the data in this smart contract and process if some people needs to be compensated. And if needed, the smart contract will pay these customers automatically. So to process this, we have several keys to ensure safety, data safety. The first one is quite usual. It's to distribute the data storage. So in fact, we are copying the data in every contributor computer and also anchoring it on the blockchain. So this enables the data to be immutable. That is to say that if you have to change the data, somebody wants to attack by changing the data, it cannot, because he would have to change the data on every point where it is stored. That's great to immutability. We have also proof of contribution, which grants that the workers, the contributors are doing good jobs and are good willing. We are going to see that just after that. And state channel, which grants that no party can cheat the other and that communication are safe. This will be explained also. So that two last elements, proof of contribution and state channel, are nowadays hot topics in Ethereum blockchain because it enables the blockchain to be more scalable because we are putting some tasks off-chain. So it's very interesting for us to develop this subject. Let's go into details of proof of contribution. So basically, when you're watching an information on the TV or when you're reading something, what makes you believe in that this information is reliable? You have several ways to believe something. Maybe you have several people who tells you the same thing. Or you can ask the question to some people who have financial interest in telling you the truth. And finally, you can also watch the history of your relationship with the person. If somebody tells you regularly the truth, you can guess that next time it will be the truth also. So basically, this is the proof of contribution mechanisms. I won't go too much in the details of proof of contribution, but if you have some questions, we are there. So now we are going to talk about the main contribution we want to do for Ethereum community, which is the state channel. I'm not sure that everyone here knows what is state channel, so I'm going to go back to the definition. So basically, a state channel is a way for two or more entities to make a state evolve off-chain until in synchronization with the blockchain. So there is a lot of keywords here. First, the state, which is in the expression state channel. What is it? So in a smart contract, a state, it's the data you store, you work with. So it's quite important in your smart contract. So it's the data. The state channel enables the members to make some updates on the state, but without contacting the blockchain. And this is very interesting because you save money, you don't have fees to pay, gas to pay. You save some time because Ethereum blockchain is getting slow nowadays. And you permit the blockchain to do something else, and so to be more scalable. And regularly, you have to synchronize your blockchain in order to stay as safe as a smart contract. So we are going to take daily life example. In fact, bakers, they use state channel every day. For example, the morning, let's say your baker is withdrawing some money from its ATM, he puts it in the cash register, and all day long he will have some transactions with the customers. He will receive some money, give back some change, and his balance will go up. But the bank is not informed of this balance going up. And it's only when the banker will go back to the bank to deposit money that the bank is aware of the actual account balance. So this is kind of a state channel. You have a lot of transactions that the blockchain is not aware of, and only sometimes, once a day for example, you synchronize the blockchain. So to be more specific about what we do at Squarescale, what we work on, it's not only a basic state channel that we could use in Squarescale. We'd like to have the ambition to do an open, generic, multi-party state channel. So a lot of keywords again. When we say open state channel, it is to say that this project will be open source. We believe that the community will have better trust in a tool which will have been developed by the community. And we could be challenged, we could receive some help, some suggestions, and this will make our tool more safer, in fact. And the generic part is because when talking about state channels, you can cover a wide variety of use cases. It can be a hand-to-hand transaction, it can be money transfer or information providing, like for Squarescale. So the tool have to be very customizable to fit your needs, and the needs are very wide. So to do that, we purpose to develop kind of a framework with some holes, some function that you can overload. And this will be able to customize everything in the state channel. For example, you could make use of state configuration, defining your own format for the state, something like a database format. And you could define the way you define the jobs, that you distribute them, adding maybe some scheduling, and validation of the results. All these functions has to be very precise and fit your needs particularly. Another way you have to customize your state channel is the level of security you want. For example, there are some state channels that you use with 2 or 3 members of your family, or with some very well-known partners, and there you can be sure that these members will cooperate with you. But if you open your state channel to some thousands of contributors, like for Squarescale, you can't be sure that there will be always online collaborating with you, and you have to be resilient to their failures, for example. Next, the multi-party keyword. So this is just to say that you can have several members, more than 2, who work on the same state to update it. So this tool doesn't really exist now. You have Widen who make state channel, but it's only one-to-one relationship. So this customizable aspect will be maybe our strength, and the open source also. So now we are going to explain how do we grant the safety of the data, even if we are off-chain. So basically, it's the use of cryptographic signature. So cryptographic signature, it's to say that you can prove at any time that a member agreed with the version of the state at a given time. And you can exercise your rights on the state who has been approved. You have version comparisons, because each member of the state channel has to agree on the same state. This is very important. And that way, you can grant that no one can lose too much. In fact, you can lose more than 1 job value. To take back the example of the baker, if the baker don't give you your bread, you just stop pay him. And the same way, if you have been cheated by a member of the state channel, you just quit the state channel. So this is a draft of what could be a job execution process. So as we said, it's a work in progress, but it gives a good example. I have called request as the creator of the state channel, the owner of the state channel. So the process starts with a contributor who asks for a job to do. It can be compared to the get work function in the mining world. And he receives a signed job specification, a mission to do. And when receiving the results, the requester can integrate the job result to the state. And he will send back return contributor a signed version of the state, updated. And this signed version of the state is the key for the contributor to, 1, verify that its contribution has been taken into account, and 2, exercise its rights on it later if needed when synchronizing with the blockchain. So this was the technical details about our mission, about our contribution to data safety off-chain. And I will now let Gerald conclude with the next steps of the project.
Well, thank you, Victor. I think we're running out of time, so let's just move to the questions. If you guys have some questions, here's our roadmap. But you can we're going to publish this anyway on our paper in the coming days. Just if you guys have any questions, please feel free to ask. Just before you, so I'm going to answer the first question that you still haven't asked, but that's going to save us some time. We talk a lot about infrastructure, and we talk a lot about multi-cloud. Well, I know it's not fully decentralized. I know we are working with, again, major players like AWS and so on and so forth. The thing is, we are focusing on heavy-duty production environment, okay? Heavy-duty production environment means that we have to be able, again, to provide a quality standard that needs we need to make sure that what we provide as a quality standard is enough for big applications with massive number of customers to run smoothly. And so far, the state of the art of the blockchain doesn't allow us to do that. We hope that in the coming years it's going to come, and we are going to go step by steps towards less and less centralization. And just, you know, by adding some touches like the state channel, like the fact that you can split between several providers and so on and so forth, we are trying to make our best effort. Okay, questions? No, no, it's not quite that. It's not quite that. I mean, oh. You mean? Well, I guess there's no whole solution, alternative. There are some solutions that will allow you to use, for example, distributed computing with people like iExec, you know. We're talking with them because we've known each other for a couple of months. We're neighbors, by the way. And so we're looking into the opportunities of using part of their decentralized computing power to pump it up into our own infrastructure. But so far, there's no global solution allowing you to have both storage, computing, what we call also sorry about that, I'm missing the word. Well, part of the scalability process that we need for the microservices. There's no global solution allowing people to do that so far. Okay, thank you very much, guys, for your attention.
All right. Good afternoon, everyone. Hi. We'll get started. So today, by the way, I'm Trent. Nice to meet you all. It's really a pleasure to be here at ETHCC to join in and have a conversation with all of you folks about what we're up to, but also improving the overall ecosystem. And my talk today is actually about that, based on some experiences that I've had and my team has had in the last year with respect to token design. And so let's get started. My title is Towards a Practice of Token Engineering. You might ask why there are jellyfish all over my slides and this one. I just think jellyfish are cool, frankly. If an AI could be an animal, it would probably be a jellyfish. That's really the main reason. So let's get started. Let's see here. Maybe I'll just use the keys. Does that work? There we go. So this key is now working. All right. Technology. So let's get started. So a bit of motivating slides around data and incentives, and of course, more jellyfish. Back in the late 90s, I had my very first job doing professional AI research. And I was overjoyed, right? People were paying money to basically play around with neural networks and evolutionary algorithms, all these sorts of things. And I was given a data set of 20,000 data points. And I was told, go and classify between these 13 different classes. And it was audio radar data. So there was, it was data from birds flying around and tanks driving around and so on. And the AI model had to classify between these. And I iterated and iterated. And initially, my initial models had 55% accuracy. That is 45% error. It was a summer job. So at the end of the summer, after 4 months of toil, working 12-hour days, I was happy to do that because it was AI and I loved it. I got it up to 65% accuracy. So within 1 summer of work, I improved the accuracy by 10%. That was still 35% error, which is unusable. And that was actually kind of the practice of how AI research was done in the 90s and even the early 2000s. Fixed size data sets, and do what you can to try to come up with fancy algorithms to improve the accuracy, right? Now, something happened though. There was a paper that came out of Microsoft in 2001, And this image is from the paper. And what it shows is something that is, frankly, super embarrassing to anyone who likes to design AI algorithms. What it shows is, on the x-axis is the number of data points, basically, number of words. The y-axis is accuracy. And basically, for years and years and years, we AI researchers were, on the left axis, we had a fixed size data set. We were right up there. We had a fixed size data set, and we were competing over 5% error or 2% error. And all of our algorithms were not performing, so there was very little AI that was actually shipping. But what these researchers said was, you know what? Instead of changing the algorithms, let's just add more data. And not just 10% more data, 10x more data, 100, 1,000x more data. And guess what? As more data was added, the models, of course, got better and better and better. So as you see, we went from 75% accuracy all the way up to 95, 97% accuracy. And the interesting thing was, it didn't really matter which algorithm you had. In fact, the simpler algorithms performed slightly better. This is super embarrassing, because people who have PhDs in AI algorithms, suddenly, it's like, it doesn't matter. Google picked up on this in the mid-2000s. They wrote a paper called The Unreasonable Effectiveness of Data, where it referenced this work and a few other ones. And their modus operandi after that was go around and gather as much data as you can. What did they do? They went and bought satellite companies. They went and bought mapping companies, all of this, to gather more data, more data, more data. They call themselves an AI company. That's a head fake. They are a data company through and through. Now, why do they care about that? Well, if you have more data, then you have better accuracy, as we saw. And with that, if you're Google otherwise, then you can sell more ads, right? Higher click-through rate, all of that, right? So, and you get this data network effect of more data, more accuracy, more money, and it's hard for people, anyone else, to catch up. You know, Microsoft has been chasing Google with Bing for more than a decade, unsuccessfully. So there's sort of this default incentive to hoard the data. You don't want to share it with other people, because then their models will get accurate too, right? That's kind of the core problem. And so we have all these data silos now everywhere on the planet, and data itself is considered the world's most valuable resource. This is from an Economist article a year or so ago. And it all comes down to incentives, right? Charlie Munger, who worked with Warren Buffett for decades with one of the world's most successful investment funds, says, show me the incentive and I will show you the outcome, right? So the question is, what can we do about the incentives here? What can we do about moving away from this incentive of siloing data? Well, blockchains are a funny thing. They are incentive machines. What you can do is you can get people to do stuff by rewarding them with tokens, magic internet money, right? This is a superpower. You know, there's lots of other cool benefits of blockchain, provenance and smart contracts and all this, but to me, the most powerful benefit of all is getting people to do stuff. So then, going back to the problem of data, let's change the incentives using an incentive machine, a blockchain, and let's change the incentives such that people want to pool the data rather than simply siloing it. They get benefit from that. And that is the underlying goal of what we're up to with Ocean Protocol. So we started working on Ocean Protocol, and I'm going to describe a few early iterations that we had and some pain that we had, and then what we did about it. So like all of you, I'm sure, we love to whiteboard, so we were drawing out, this is an example of an early algorithm that we had, trying to address some concerns around, you know, if you have 10 people contributing 10 data sets, how does each data set contributor get paid? Can you defer the payment till the end, royalty style, all of that? So this is an example algorithm that uses some AI to extract impacts. And there's other things here too. We're starting to list homework encryption and a whole bunch of other things, right? So lots and lots of whiteboarding, bring in friends from all around the world to iterate with and so on. Also very early on, towards the first talk of the day, we wrote down goals, and two of our main goals were a healthy ecosystem, not just initially, but long term, right? And then also, all throughout this, maintain ethics and values, right? That was always absolutely critical to us. And we kept iterating, so this is that whiteboard expanded, a whole bunch of other things. You don't have to try to read my writing here, it's terrible, and this is also other people's writing. So iterating, right? Looking at multi-party compute and all this sort of thing too. And also looking at various pricing schemes with auctions, asking ourselves, you know, what if we had data that looked like Steemit? What if we approached data the way that Numerai does it? Et cetera, et cetera. So just lots and lots of iterations here and there, right? And various sorts of designs. And as time went on, we started to actually distill a set of questions, right? So here on the top part, you see, how do we ensure that the data supplier gets paid? What about the problem of free riding and so on? And on the bottom of this whiteboard, you'll see on the left, we're starting to list different signals. I'm an electrical engineer by trade, and in the world of electrical engineering, you have signals in terms of voltage or in current, and then there's other ways to view it. And then we started to write down different tools and patterns that we might use. This is the bottom right. So we were starting to get there, but the challenge was it still felt like we were flailing, right? What is it that we were trying to achieve? When did we know when we were done our token design, right? When should we move on from that first white paper to actually writing code? And so we asked ourselves, is there a way to structure this better, to look at this and improve the process? And around the same time, I started to realize tokenized ecosystems are a lot like evolutionary algorithms. And I had spent a lot of time in the world of AI, including evolutionary algorithms. Roughly speaking, an evolutionary algorithm, or EA, is survival of the fittest, right? You can have a bunch of individuals running around, doing whatever they want, and every generation, maybe you kill off 5% or 50%, the ones doing the worst, and you let the other ones make babies, have some mutations, some crossover, some changes, and you keep repeating, and over time, you converge towards an answer. So that's the general idea of evolutionary algorithms. They go back to the 60s, independently invented in 3 different places, and they're actually wildly powerful, and Moore's law is their friend too, by the way. So I realized that tokenized ecosystems were a lot like evolutionary algorithms. It wasn't just myself either. Simon de Louvier started to notice this too, and some others. So this table here shows you very explicit examples. So when you've got a tokenized ecosystem, you've got this block reward function. Guess what? That's just like the fitness function or objective function of an evolutionary algorithm. So just like you're trying to say minimize the error of training a neural network, in the case of Bitcoin, you're trying to maximize the hash rate for security. And then when you go to measure this thing, how well is it doing? In an evolutionary algorithm, you're measuring the fitness, right? What's the error? In the case of tokenized ecosystem, it's really the proof that something was done, some sort of proof of work, for example, right? You've got system agents, right? So in evolutionary algorithms, you've got these individuals. They run around, there's 50 of them or 5,000 of them, and they do their things, and you keep the good ones, you get rid of the bad. Well, with the world of blockchains, this is actually humans and actors, the miners, the token holders, and so on, right? They're running around, they're doing their thing. And there's even a system clock, right? In evolutionary algorithms, you have a generational update. Every generation, you make babies, you evaluate, et cetera. And actually in blockchains, we generally have block reward intervals, right? Every 10 minutes for Bitcoin and so on. And finally, and this is the key thing, or another thing, in the evolutionary algorithm, for incentives, we can't control these individuals, right? They can mutate, they can cross over, they can do whatever they want, right? But what we can do is reward them for acting well, so let them make babies, reproduce, and so on. Or the ones that are doing badly, you just kill them off, right? And it's amazing, with an evolutionary algorithm, even if you only kill off the worst 5% every generation, you get incredibly good performance, right? Well, we can actually have similar things in the world of tokenized ecosystems. Well, we do have similar things. We can reward by giving tokens, and we can punish by things like slashing stake or kicking out of a registry. There's other ways. So rewards, incentives, and disincentives. So when we realize this, we realize then, if these things are so similar, let's approach token design as optimization design. But that, of course, begs the question, what does optimization design look like? So luckily enough, I'd been doing this for a long time, designing evolutionary algorithms and CAD tools that had to embed these things to just work, right? And there's 3 steps if you want to design an optimizer that optimizes successfully. So the first thing is you write down the problem, you formulate the problem. This is the goals, which is objectives and constraints. And it's the design space. I'll talk about each. Then you try an existing solver. You don't want to reinvent the wheel, right? So you try it, and if needed, you try different problem formulations or solvers. I'll talk about that. And then only if you need it do you design a new solver, right? Because otherwise you're just wasting time. So this is the steps. So formulating an objective function and constraints, this is the canonical formulation up here. The top thing, it says minimize fi, I equals 1 to nf. These are the objectives, the things you want to minimize or maximize. If you're designing a car, you might want to maximize top speed. You might want to minimize fuel consumption. And then subject to constraints, inequality or equality constraints. So an inequality constraint might say power consumption has to be less than 10 milliwatts. Or the equality constraint might be if you've got a car, maybe no matter what, the tire diameter is 17 inches. And then you also you have a design space, sort of where the optimizer can run around, right? So this is formulating the problem. There is an art to doing this. It's not easy, and actually, interestingly, in the next step, as you're trying the different solvers, if the solver doesn't converge, if it doesn't do a good job, you have some options. You can try different solvers, but you can also reformulate the optimization problem. So in the world of optimization, for example, in the late 90s, people figured out how to solve convex problems in polynomial time. This was a big breakthrough, but because before that, we could only solve linear problems in polynomial time. Convex means one big hill. But before that, they didn't have a way to do it. So that was really great because there was this big push by people to try to figure out how do you formulate a whole bunch of problems in convex form so you could solve them very quickly. So, or maybe your solver doesn't work very well, so you try to use another one, right? Maybe instead of an evolutionary algorithm, you use stochastic gradient descent or something. And if it does well in the end, it converges. So this is an example here of an evolutionary algorithm running over 500 generations, trying to minimize its objective function. And if it turns out that you can't solve it, it just doesn't work, then you need to design a new solver, right? So this is an example of a solver that I designed in a paper from about 10 years ago. And it just happened to be addressing the problem that I needed to solve. At the time, there was no really good way to have something that could search through a grammatically constrained space in a way that wouldn't get stuck easily. So this solver basically did that as an example. And then if you're successful, at the end of your optimization run or runs, you get really cool results. So this is an example where you have two objectives: maximize the gain bandwidth and minimize power. So the ideal thing is down on the bottom right, the ideal point. But there's always trade-offs. So in this case, every single dot you see is a different result that worked. But this is an example of an optimization, or 3 optimization runs that worked really, really well, right? So if you are successful in the design of these optimizers, you get good results. So back to token design. Remember, we realized token design looks like optimization design. I've laid out what does optimization design look like. So let's apply the same steps, roughly speaking, to token design. What are they again? Formulate the problem, try an existing pattern, not solver, and design new patterns. And a pattern is a building block, and they can be various levels of the hierarchy. I'll talk about that. So these are the 3 steps. What does this look like for token land? Let's go through them. So formulating the problem, right? In this case, we have to first of all ask, you're trying to come up with the objectives and constraints, right? Ask, who are your stakeholders, right? What do each of them want? And also, what are the different attack vectors? Because every single attack vector is going to turn into a constraint. Do I prevent this, yes or no, right? And then from that, you can translate these things into objectives and constraints. I will give examples in this later for Ocean, by the way. And then trying existing patterns, right? So we actually were enumerating our own lists of patterns that are out there, and there's actually quite a few emerging. Some people are calling these crypto-economic primitives. I like the word patterns because it goes back to design patterns in software or architecture. So some examples, there's a bunch of patterns for curation. There's patterns for proofs of compute work, et cetera. There's also patterns for identity, for reputation, for governance, for third-party arbitration, and more, right? And within each of these, you have to ask, is this appropriate for me? Sometimes they might form the core of your system, or they might be bolt-ins that you have on the side towards addressing a particular attack vector, for example. Let's drill in on a couple. So curation. We've seen in the last year, even the last 6 months, that token-curated registries just took off, right? ETH Denver, something like 1/3 of the projects use TCRs. Great, that's very, very cool because if it works, that's all you need, right? But it doesn't just stop at TCRs, right? You can actually say, what if we want to promote people, just like people going from early Wikipedia contributors to higher and higher levels of editors, right? You can go from, you can get promoted, and there's something out there called stake machines that does that. So it's a generalization of TCRs for that. Or you can also have continuous valued membership, right? This is curation markets, right? And they're characterized by a bonding curve. And you can even go further. You can actually have hierarchical membership. And this is something we realize. You can actually introduce labels, which are very popular in AI, actually. Something that I'll talk about later is proofed curation markets. So with Ocean, it turned out that none of these other patterns quite worked for what we needed. So we actually we had to invent a new pattern, but it's something that can get deployed elsewhere. I'll talk more about that. And more recently, some folks introduced something called refungible tokens, which is taking non-fungible tokens and adding fungibility. So this is an example of just emerging patterns for just curation, right? But of course, there's other things too, such as the patterns for proofs of work. And within a subset of that, there's proofs of compute work. So we went in and actually enumerated these, right? Subsets, there's work around data and there's work around computation itself. Within data, we've got, for example, proof of space-time, which is famous within Filecoin. But there's also proof of replication, proof of data availability, which is a subset of proof of space-time, and more. Same thing for computation. There was talks in earlier talks on this. Things like zero-knowledge proofs, and there's subsets of that, ZK-Starks, or interactive proofs like homomorphic encryption, and so on and so forth. So there's a whole bunch of patterns out there, and it's really useful to understand these, to have these in your toolbox when you're doing token design. So with this flow, these 3 steps I talked about, let's start analyzing, let's use this in a case study to look at a little bit at Bitcoin, and then on the heels of that, I'm going to drill into a full-on flow for how we went about a systematic approach to designing Ocean. So Bitcoin actually has an objective function. Its objective function is to maximize the security of the Bitcoin network, right? It defines security as hash rate, which is compute power, which is electricity, right? And overall, it's making it super expensive in terms of electricity spend. It's super expensive to roll back changes to the transaction log. That's basically what Bitcoin is trying to do, right? You can even actually formulate it, write it as an objective function like I have here, where the expected value of the block rewards, i.e. Your chance of getting Bitcoin in this case, is proportional to the hash power of your actor, which is your contribution to security, your work function, and times the token dispensed at that block in that time interval, right? So this is actually the Bitcoin reward function expressed as an objective function, right? And I say expected value on the left because it averages out over time, right? If you actually want to have a very low variance, you join a mining pool at the top. But overall, it's very lumpy otherwise at the lowest level. How well did it work? Bitcoin's incentives? Well, this is a picture of a mining center, right? ASIC farm. So people are maximizing security. That is, people are maximizing electricity. And the sheer power of incentives of Bitcoin, it's going to use more, it's on track to use more power than USA by mid-2019. Isn't that incredible? It's already using more power than most small countries, right? But by mid-2019, more than all of USA. And this is, by the way, a for better or for worse thing, right? There's big debates about this. But it shows the sheer power of incentives. But also, when you're designing these things, think about the ethics and the values and what might come out of this, right? Let's now talk about Ocean and going through Ocean design as a case study. So first of all, formulating the problem, we actually wrote down the list of the different stakeholders. So they are the people with the data, the service providers, the custodians, all of that. The people doing the referring / curating. And this, by the way, could be data exchanges and so on too. There's people verifying the data, making sure that it's good, that it's not failing and so on. There's people consuming the data, and finally there's the keepers or the miners, right? And each one of them has gives and gets, right? So for example, the data service providers, well, they're providing the data. What do they get in return? Well, probably some form of tokens, Ocean tokens, et cetera. Et cetera, et cetera. So for each of these stakeholders, they have a give and a get. This is just the key stakeholders, by the way. We have another 10, but most of them actually aren't as important, especially in the core of the system, right? So you have to remember there's things that will be on-chain and off-chain, and there can be a whole ecosystem around. Think about Bitcoin, right? At the core of Bitcoin, it's super simple. But this whole ecosystem is formed around Bitcoin with wallets and miners and pools and exchanges and all of this, right? So it's really important to understand that, and a key part of this is where do you want to be, where should your stakeholders be playing a role in the core network? So in terms of formulating the problem, once you've got the stakeholders, then it's translating into objectives and constraints, right? So for Ocean, it actually came down to a phrase that we repeat to ourselves again and again and again: maximize the supply of relevant data, right? And you'll see shortly that generalizes services too. So overall, we wanted at first token rewards if you supply relevant data. The thing is, how do you know what relevant data is? So very quickly we realized we have to leave that to the crowd, right? So the crowd actually has to play a curation function on the data itself. So really, it's token rewards if you supply data and curate it. And by supply, I don't mean just publish, but I mean also make it available. So, and that was sort of the high-level objective, but we had a whole bunch of constraints. And at the highest level, we distilled into 7 constraints. So for priced data, is there an incentive for supplying more data? Is there an incentive for referring? Is there good spam prevention, right? Because you don't want to pay people every time they submit data, even if it's junk data, that's garbage, right? So that's for price data. But with Ocean, we also want to incentivize the data commons, right? So for free data, the data commons, is there incentive for supplying more? Is there incentive for referring? Is there good spam prevention, right? Besides that, we also want to incentivize for actual actors in the ecosystem rather than just the hodlers, right? So what this means, in the words of Fred Ursam, does the token give higher margin of value to the users of the network versus external investors, right? Or another way of framing it, or a specific way is, does the return on capital increase as stake increases, right? And then other things, are people actually incentivized to run keepers? Is it simple or as simple as possible? Is onboarding low friction? So these are the key constraints or checklist we had. But then beyond that, we actually just brainstormed and grouped the ideas. So, you know, what other objectives do we have towards good acting via staking, identity, reputation, and so on? What are the list of attacks? We actually have 3 pages of attacks that we've written down. So, so just page after page of attack. Others have made checklists too. William McGuire made a checklist more sort of token economics related, but it turned out to be quite useful too. So just long checklists. And finally, of course, the key values. So we actually wrote down the key things we wanted there too. This really matters to us, right? So it's really important for the unlocking of data and the human right to personal data privacy and consent, but also the spread of power and the spread of value, right? We've seen some token launches out there where one actor got 20 or 30 or 40% of the initial tokens offered, and that does not spread the value, right? So what can you do about that? And then some other things too, things like resilience, work with the law, et cetera. So that was the step one, right? Formulate the problem, right? The objectives, the constraints, the design space. And then try some existing patterns. As you guys saw, there's a lot of patterns out there, subsets of subsets. So here's some ones we looked at, right? Take a TCR, token curated registry, for just actors, right? The good players versus the bad, so only the good ones are in there. And some systems out there do a nice job. AdChain, I really respect them for having just that on-chain and everything else is off-chain, right? That's pretty cool. So we asked, could it be as simple as that, right? Or what about just for data, right? Or what if we had a registry for actors and for data, just that, right? And maybe bring in some curation market stuff, right? So this was some initial patterns that we looked at. And of course, what do you do with these, right? How do you know whether they're good or not? Well, guess what? We have our objectives and constraints, right? So here, we actually, these key questions we asked. For the price data, is there an incentive for supplying more, referring, right? Well, for that first design, the actors registry, it actually doesn't, there's no incentive. It doesn't help there, right? For that first design, the actors registry, it actually does an okay job in spam prevention. It doesn't help for supplying free data as well. So it's failing on some things, passing on others, right? And so each of these design, you can see there's some passes, but there's some fails. There's some X's or so-so, right? So of all the different sort of patterns that we looked at initially against these constraints, they weren't working. They weren't working. So we started saying, what other new patterns can we introduce? What minimal changes can we make in order to address our concerns? And we started realizing that if we bound together the actual work of making data available with curation, that's a new pattern, and it's very powerful because it's combining a prediction of something having relevance with something actually being relevant or popular. And we had a couple of variants of this, and the variant number 6 is what we're calling a proofed curation market. And so then, against the constraints, we see variant number 6 is that actually hits the checklist for every single one of these goals. Once we got through this, then we went through the longer checklists, and it turns out to do a nice job there too, after some tweaks here and there and here and there, right? So this is actually how we arrived at this. This particular design was actually initially flailing, then formulating the problem very tightly, having key questions to ask, and then trying different patterns and iterating. Coming down to, I showed you the objective function for Bitcoin. This is the one for Ocean, actually. And what this is we're trying to reward curating of data and making it available, right? So on the left is the expected reward for the user I on dataset J. And then the yellow is a reward. The reward is proportional to predicted popularity, which is how much stake you have in the curation market. Are you putting your money where your mouth is? But on its own, curation markets, they can flail if it's not tied to actual work, depending on the application. So we tied the predicted popularity with the proofed popularity, which is actually, did you make the data set available when asked, right? So, and that's the yellow, the green here, sorry. By the way, the log stuff is in there in order to avoid stake whales. You don't want the rich get richer in a strong way. So log actually, it turns out, AI folks use it all the time for diversity, and it actually has relevance with something called the Kelly criterion in economics. So that's the core of it, and then we've got the tokens during the interval, and then the far right, there's this R thing, and this is actually an extra term we have to prevent a couple of attacks that we tacked on later. But overall, the core is, for Ocean is, did you put your money where your mouth is for something being relevant? And then was it actually relevant, right? That's the core. But we had one more constraint, if you saw in the checklist before, and that was, what about privacy, right? And it turns out that for certain problems, the only way to address privacy properly is on-premise compute, right? Also, though, as we were iterating, a lot of data is super heavy. You can't actually, it's a petabyte or more, and you really don't want to move it. So that's another reason to have on-premise compute. We also realized there's a lot of emerging networks out there for data, for compute, and so on. Is there a way where we can hook into that and basically grow together as an ecosystem together? And what we realized was we could generalize what we've been building rather than just maximizing the supply of relevant data. It could be relevant services, which includes data and compute. For our case, tuned towards AI. And so overall then, the objective function simply changes from, instead of predicted popularity of the data, just data, it's for the service. And same thing for the proofed popularity. And like you saw before, we actually have proofs for not just data, but for compute, right? So we knew we could leverage those patterns. So the core design of Ocean did not change that way, but by generalizing in just a specific way, it addressed these new challenges. So overall, as I was iterating on this, just in the last few weeks actually, we've started to realize that there's a new label needed for this, right? So out there's actually a field that's been around for forever. There's game theory, which is really about analysis of tokenized ecosystems and other things. And then, but there's a synthesis side too, which is mechanism design, right? The thing is, a lot of the mechanism designers and stuff out there, this is really people in this science, not engineering discipline, of economics. And how often do you get a chance to actually deploy an economy? It's pretty rare, right? But if you think about it, optimization design, people are deploying optimizers all the time, right? There's actually a big practice around that. How do they relate? Well, it turns out that if you take ideas from mechanism design, that framing, and add just a few constraints, it actually casts into the problem of optimization design. So this is very cool. These fields directly relate, right? But I also saw that, like, where is the engineering, theory, practice, tools, right? Where is the responsibility that you take on if you're an engineer? Like Canadian engineers, we get iron rings so that we always remember. And if you start doing this, then you take the optimization design framing, and it actually turns into what I hope will emerge as its own engineering discipline, token engineering. And this is what I see. So it's sort of going from this science, economics, which is game theory and mechanism design, to engineering, which has, overall, engineering has this goal of building systems that just work. So, to conclude, I have a dream, a vision of a practice of token engineering. How can we get there? Token design looks a lot like optimization design. By doing that, we can actually have a process for designing these tokenized ecosystems, formulating the problem, objectives, constraints, design space, trying existing patterns, iterating. Don't invent if you don't have to, right? And only if needed, you try a new design, right? Iterating there. This helped a lot for Ocean, we've seen, so far. We haven't deployed it yet, so I'm not going to make any grand claims that way. And overall then, token engineering is theory and practice and tools and responsibility towards design of tokenized ecosystems. That's token engineering. Thank you.
Hi, thank you for the nice talk. You seem to move the engineering on the token side, a lower hierarchical level of mechanism design. So the question is, in what way we can engineer the mechanism design to achieve the complexity of the system?
Yeah, so it's not on a lower level. How I see it, there's mechanism design is really within the field of economics, which is really a science, right? And science is really about answering questions and gaining knowledge for humanity, right? Engineering is about building practical systems that work. So I see that the mechanism, like what I have a dream of is the mechanism designers working very closely with this sort of emerging field, and maybe in the end it will be called just mechanism design, maybe just token engineering, I don't know, but engineering has a lot to say in terms of the ethics and how to approach this stuff, right? So I see that it's side-by-side science and engineering, and then overall in terms of complexity, within engineering, obviously in engineering you can have wildly complex systems if you want, right? Like a chip, you know, people design chips. A team of 10 engineers can design a chip with 10 billion transistors in a matter of months because they have the right theory and practice and tools, right? I see that here. We want to keep the designs right now pretty simple because we don't have very good tools. And instead we want emergent complexity above, right? So Bitcoin itself, the core design is super simple, right? So from very simple rules, we get this complex system. And that's actually what complex systems theory has a lot to say there. So in general, we should be always trying to strive to keep things as simple as possible, but no simpler. So, thank you.
Hi. Here. So in Ocean, you've taken care of the popularity with your token incentives. What about quality? So for example, I don't know, the New York Times versus BuzzFeed.
Yeah, so overall, this is actually one challenge we still have. We'd like to have, when we say relevant, right now we're measuring relevant as popular. Which is not ideal. There's actually a lot of metrics for relevance within the world of data, as well as sort of information theoretic measures too, all this sort of thing. We don't have a great answer there yet. So overall, we're leaving basically people, when they're betting on something, are they betting on it being popular or relevant? We don't know. Now, if that data is valuable, then people will want to be maybe wanting to sell it. So you can actually incorporate the relevance on the priced side of things above that. Ocean itself, if you've noticed, actually, it doesn't actually do the pricing stuff itself. That would be for data marketplaces that emerge on top. Ocean is just incentivizing for data, whether it's priced or commons data, either way. So I guess to answer your question, we don't have a great measure of relevance yet. The best is just knowing that it's staking, but for price data, then relevance comes implicitly in one level up. And if any of you guys has ideas on how to get to relevance in a better way, please come talk to me. One other thing too, in general, please come talk to me if you're interested in this idea of token engineering at all and contributing to patterns and whatnot. I do hope to build a community around this actually, just with all of us together. This is something that can really help the whole community. Question?
Thank you. So I'm wondering how much the fact that people try to get information from this creates a feedback which distorts the information. So this herd behavior that people vote for things that other people vote for might create. So do you think that it's irrelevant? Like it doesn't distort the measures that you're trying to glean out of this?
Yeah, so that was certainly a challenge, and actually that's part of the reason that we brought in the data availability. So if you actually, it's not just curating, because if you have just a curation market, with just that straight out, that encourages a lot of pump and dump stuff, right? Even if you have like cost in there of selling and stuff, but once you bind the curation with the work, then the only way for people to really extract value well is if they start serving up that data too, right? So that actually implicitly covers for it. So forcing people to actually do work to compute to the system means that they're contributing to the system in the way that the system wants, right? So this is why it's so important to actually ask yourself, like, what does the system want, right? And then optimize to that. Yeah. But great question. Victor. We're going to need a mic, actually.
Thanks. I can try to shout. So basically, popularity and all these measures are hinge on the assumption that somehow you can track the access to the data. So the age-old problem of piracy. So basically, with digital data, once you reveal it, you can distribute it and make it available for others, either in a secondary market or just for the fun of it, make it available. So this problem occurs all other fields, of course, it's not specific to yours. But do you have like a hunch on like how you want to solve it, or is it going to be solved? Does it have to be solved?
What was the last sentence? Is it going to be what?
Do you think it needs to be solved, or solved as in somehow you have to take care that uses of a particular set of data is kept in the system so that you can record its popularity? So basically data piracy.
Okay, so actually in that I see two related questions. One is, you know, this concern towards proving that the data was made available and so on, and that's why this is where the cryptographic proofs are really key. So actually we look forward to leveraging Swarm as one of supplying one of those proofs, right? As well as, so hurry up. No, but overall, you know, this I also reference, you know, proof of space-time and other stuff, or more lightweight ones. You know, Jason Toish just wrote a paper on data availability, which is a simpler problem than proof of space-time, right? So overall, there's the proof that the data was made available, and you only get paid once it's proven, right? On the other question of what if, basically there's different attack vectors, and you hinted at one around if people maybe get the data set and then spread it around outside of the system, right? Yeah, exactly, yeah. Exactly. So data leakage, data escapes. There's lots of words, and so there's two answers to that. One of them is for certain types of data, you can just let go, and it's like, okay, fine, it's out there. You have to let go, and just knowing that it's there. You know, like when iTunes took away DRM. Guess what? Nothing happened because it was convenient enough and the system was good enough that people were still incentivized to use iTunes, which is actually wonderful, right? A wonderful result. If it really matters that you don't want the data to escape, this is where you can actually, Ocean, by the way, the data, it doesn't care where the data is stored. It can be on-premise behind a firewall. It can be decentralized. It can be centralized. For super sensitive data, maybe it needs to meet GDPR standards or whatever, or German medical data needs to be on German soil, then keep it on German soil. And so if you have concerns, really strong concerns about data escapes, this is the way, right? So Ocean, it's very flexible in terms of where the data is served from, as well as it's flexible on where the compute is, right? And that's on purpose. This is why it's this framing, this sort of decentralized data hub of data and services. Vaughn.
Hey. This question is about the two different types of models you're trying to kind of perpetuate. One is around the data commons, which will have a different effect on the price of the Ocean token compared to priced data. And I think it's kind of similar to the data escapes problem. If you're always trying to build a data marketplace and data kind of has this property where it always tries to be free, or kind of the end state is you kind of create this downward pressure, doesn't everything trend to free over time? And how does that affect the token?
Yeah, so I mean, one way of, this is a great question, thank you. And overall, there's the question of, you're getting value at the level of Ocean, whether the data is free or priced, but then does that conflict with the price data one level up, right? And we wanted to make sure that it was that Ocean itself was a unified framing for free versus price data, right? And this is why we arrived at this level. It also means that there's ways to compensate creators directly. If they have something good, they stake on it early. All of this, just like people mining Bitcoin early, they're going to get more. And you know, there's been some really nice articles recently on Medium about like designing bonding curves around this and stuff too, to really help compensate the creators sort of at this base level, right? And I actually see, you know, there's this classic problem, Stuart Brand problem of information wants to be free, it also wants to be expensive, right? The free part is the physics of bits. They want to copy, copy, copy. The expensive part is because you want to compensate creators. The cool thing is we actually have a whole new answer to that now, because there's this magic internet money that gets printed that can go directly to the creators, right? Which is actually kind of cool, independent of whether the data is priced or not. So we kind of have a new deal for compensating creators. And you know, this strikes to my very heart too in a great way, going back to Ascribe days, compensating creators. Related to this all, then there's the question of the priced versus not priced data. My view is, ideally, most things move towards being free for humanity, and the price stuff gets squeezed out, frankly. I would love that. Now, there are times and places where priced still makes a difference. So this is kind of how I see things. And I'm completely okay if price gets squeezed out. Great, right?
Hi, I'm curious to hear your thoughts about incentivizing different behaviors in a complex ecosystem like Ocean, right? Like there's incentivizing the value of the data itself. There's incentivizing the running of the infrastructure that provides the data. There's probably some kind of reputation baked in. Just having token registry at all is kind of a representation of reputation. So why incentivize all of those different mechanisms with the same denomination of value instead of using a few different denominations?
Yeah, so great question. One of the there's a few reasons why we chose what we did. We saw actually early on that with AI data, it's really a supply-side problem. If you talk to any data scientist, any AI researcher, they'll be like, yes, I'll take 10x or 100x more data, please, I want it yesterday, right? So that part is actually easy in terms of the demand, or easier, right? The supply side is much harder because you've got these big corporations that have petabytes of data that they don't know what to do with, and they're very antsy about letting it out because of privacy reasons, or they just don't know, or whatever. And also even, there's lots of different open data sets, but they're not incentivized even to share their stuff right now. So for Ocean, it actually was more about the supply side than the demand side. So if you look at the objective function for Ocean, it's actually maximizing supply, not demand, and that's an explicit design on purpose. Now that said, there's still the challenge overall of, we've got the people that we want to do the keeping, we've got the people that we wanted to be supplying, and so on and so forth. And one option was, we looked at this design where we have a token reward if you do keeping, or if you do this, or if you do that, and so on. And but there's attack vectors for that, because it might be that people, maybe you have 20% to the keeping and 20% to this, and so on. There's attack vectors there that's pretty easy to game in many ways. So we said, you know what, we're going to bind this all together. So if you actually want to get paid, you're running a keeper node that you're curating, you're staking, and you're supplying. It's all bound together into basically one actor in the end. Yes, there's different roles, but we're binding into one actor. For all the other actors in the ecosystem, they aren't part of the token design itself. However, I think it's really, really important. One thing that lets you sort of fudge your way through this in a powerful way is making sure that all the actors have tokens, right? And that way you're aligning the interests of everyone. So this is why, for example, with Ocean, as we're growing the community and stuff, we're making sure that there's tens of thousands of people involved, and we actually have community greater than 10,000 already around this. And there will be airdrops and all this sort of thing too, we expect. So it doesn't, overall, that's the way of aligning all the various stakeholders over time, right? And ultimately, the main way is simply like, are they happy with the system? Is it working? Is it useful, right? But with the token design, I think you have to be very, very careful. If you're gonna have token rewards for more than one role, there's a bunch of attack vectors. You got to be super careful there, right? And we're not, like, keep in mind too, you can have, if it turns out that we want to incentivize demand side better, well, maybe you have a network on top somehow, right? Or maybe there's a whole bunch of different possibilities for designs. We're seeing the emergence of ecosystems with two tokens, right? Like a stable coin and something else. So we're open to all this. We're trying to keep it simple now, but who knows, right? None of this we see as cast in stone. We're going to iterate, measure, and so on. I guess there's two.
I have a question about iteration, actually. So you talked about, I mean, just in drawing the equivalence between token engineering and optimization design. So when you're doing optimization design on something like a printed circuit or a well-defined problem, a diode or a resistor behaves in the same way, and that's very easy to simulate, and so you can do many, many iterations. But if you're trying to design a token economy, people don't behave in predictable ways. And so I wonder if you have any thoughts on how you iterate with economies and how you iterate with a token design when you can't really do that many experiments or do that many iterations.
Agreed. So I view this as a great challenge. It's a great question, actually. It turns out, actually, circuit design, while it's a closed system, it's actually really hard to model well. So even if you're trying to like synthesize an analog circuit or something, it's actually really hard to have constraints such that it's not giving you completely wonky designs like Rube Goldberg machines. And I know this super well because this was my PhD thesis, and I was actually banging my head against the wall for years trying to solve this, and I cracked it eventually. But so even for circuits, it's actually hard to capture everything, which is maybe a bit of a hint of the solution. That said, when you've got a more open loop system where you've got humans involved, and humans, you can't always predict humans because we would have to model the brains of everybody, and that's just going quite crazy. Then what, right? And so it's a great question. And I've been iterating with several people about this over the last few weeks, and there's high variance in opinions, right? One friend, he tells me, this is impossible, this is fantasy land, right? Other friends are like, I'm gonna build a simulator tomorrow on this, I'm gonna do my best, right? And I see that overall, we need to try, right, for starters, because if we don't try, we end up with more things like Bitcoin, this life form that's eating the energy of the planet, right? I don't want that anymore, right? So if we can try, if we can anticipate these, great. So there's a near-term solution and then a medium-term. The near-term solution is something that we're doing, and I'm seeing other groups doing this too. With Ocean, we had a draft white paper, and then we would send it to a few friends who really get the stuff. And they would attack it in various ways, like, what about this, what about that? We would add that to the list of attacks, we would update the design to fix it. And we kept doing this again and again and again, right? And we're seeing other groups doing this too, the TrueBit guys, the OSCoin guys, and so on. And I think that's actually a really great practice, because then you're adding constraints. At the end of the day, though, hopefully that's enough, but I think also even when you deploy the system, you might find new attacks. The system itself needs to be evolvable enough, right? So the good thing is, even by default, like hard forks are a path to evolving. It can be painful, but it's working. We're seeing on-chain governance maybe starting to work, things like Dashcoin and stuff, great. I don't know what the right answer there is, but overall, some form of governance, whether it's hard forkish or something a bit more involved, that's gonna be crucial to actually adapting to the system. I also am hopeful too, but beyond just iterating with friends and stuff, I do hope that we get something like a token simulator, a token economy simulator. And it could be like agent-based simulation, things like we've seen before, but these agents then, how do you design the agents, right? And maybe you can turn that into a game on its own where humans get involved. Maybe it's Mechanical Turk style, where actually part of the simulation is actually people trying to attack in various ways. And then maybe bit by bit, you bounty it up towards the launch of the network itself, right? Because you have to incentivize people well enough. If they come up with a great attack that they're getting paid maybe $1,000 for, would they do that, or would they wait till the system goes live and make $1 million, right? So how do you use that? And I think that there's a lot to be said with bounties for bugs, sort of like Cobalt.io does, right? But more towards token bugs. So there's bugs in terms of the formal verification, smart contract part, but what about the token dynamics bugs, right? And it's like digital versus analog design. So overall, I see pieces, right? To summarize, iterating with friends to attack you, evolvability in the system itself via governance, and then finally token simulation itself that includes human in the loop, right? One other thing I should mention, these things here that I'm talking about, I actually wrote a blog post that came out last week that discusses a lot of this in length. So, and like before too, if any of you guys has interest in iterating more on this, let's do this. Let's form community around this.
Thanks, Trent. First of all, amazing presentation. Really enjoyed it. So my question is, I think as more and more protocols emerge that have specific use cases, like Ocean, for example, for the exchange of data. Interoperability is going to become an increasing topic. And now, as we see different protocols interoperate and kind of use each other's functionalities, those those protocols have their own token systems and incentives, obviously. How can we, in sort of token engineering, take like other token economies into account? So like bake in the concept of token interoperability and the incentives from moving from one protocol to another into the actual design before even launching it.
Wow. If you have an answer to that, please tell me, or if anyone does. That's a great question. I don't know. I do see that interoperability is actually at the heart of Ocean too, because we're trying to iterate with these other networks, right? So we want compute coming from Golem or from SingularityNet or from Enigma, and we want data coming from Swarm and from Filecoin and all these, right? It's actually really important. And then we see that there's interoperability protocols emerging, right? Interledger, Cosmos, Polkadot, all of these. TrueBit as a glue technology too. So each of these the near term is we're not going to have tokens that incentivize this overall yet. There's a sub-challenge too. If someone's using Ocean and they want to make a call to say Golem, how do those get paid for? And you know, the good thing is there's decentralized exchanges happening and built into things like Infura and stuff too. That's actually very nice, but that's not about the incentive, that's just about interoperating. So I don't know, but maybe there's something around like baskets of currencies maybe, right? Like Prism style. So if any of you have ideas yourself or others, please let's talk about it. That's a great idea actually.
Just that I think that we can learn from the kind of real company world where I think in music, Spotify and Tencent Music did like a share exchange. So I think seeing projects who do an active exchange of their tokens could be really interesting. So they're incentivized to actually build across protocols, and I'm sure those things could be quite interesting to explore.
That's a great idea, yeah. The share swap taking a token land, right? And a token network that's incentivizing share swaps across, that would be amazing, right? So.
Okay, this is a very hot QA session, so I will accept more questions. It is the last conference for this morning.
Sorry? Oh.
I mean, are you accepting more questions for the session?
If people have more questions, great. Yeah, I mean, so I'm open.
So if anyone has other questions.
Thank you, everyone.